Welcome to Ask and Learn.
So now there's a function f of x equals 1 minus x to the 2/3, and we're being asked to show that f of negative 1 is equal to f of 1, but there's no number c in negative 1 to 1 such that f prime of c is equal to 0. And the question is, why does this not contradict Rolle's theorem? So just by looking at this function, we know that this function is continuous in this interval because this is actually a square root, some sort of root function, and we can have values from negative 1 to 1 because this is a cube root. So cube roots are defined on all real numbers. So we know that this is continuous, so that's for sure. We cannot assume differentiability. This is a little tricky. We're going to talk about this in a second. So we're going to come back to 2. Oops, sorry about that. And then we're going to check if f of negative 1 equals f of 1 right away. So if we plug in the value of negative 1, so f of negative 1 into our function, so 1 minus negative 1 to the 2/3. And since this 2 on top squares the inside, and the cube root of positive 1 is 1, it will just be 1 minus 1, which is 0. And then f of 1 will be the same thing. Be 1 to the 2/3, which will be 1 minus 1, which is also equal to 0. So now we know that this last condition is satisfied. So the differentiability over negative 1 to 1 is a little tricky in this case. We can't assume it in this case right away. So why don't we just first take the derivative? So f prime of x. So now all we do is apply our polynomial rule, since this is we can just bring this down. So this will be 0. Bring down 2/3. And then we subtract 1. The 2/3 minus 1 is just negative 1/3, which is, this is the same thing as negative 2. Remember, there's a negative right here. Oh no, this is, because we bring down this negative 1. So important note, this is 3x to the 1/3. And now there's actually something very interesting going on in this function. Since this value of x, if you actually draw the function, the cube root of x, there is no value of x such that will give us 0. Because even if you think about this, just looking at this function, negative 2 over 3x 1/3, we can't solve for x equals 0. Like, we can't find a value where x is equal to 0, because when we multiply this times 3x to the 1/3, we multiply to 0. And then we're left with negative 2 equals 0, which is just nonsense. Doesn't make sense. So we know that there's no value of x just will give us a value that equals 0. So although there is a derivative, it is not differentiable from negative 1 to 1. So what's actually happening here is that this second condition is not satisfied. And so initially it seems like there is it is differentiable and we can take derivative, but there's no point in which it is equal to 0. There's no f prime of c that equals 0. So this actually doesn't contradict Rolle's theorem, because the second condition is not even satisfied, because this is asking us that it has to be differentiable from negative 1 to 1, but there is no value from negative 1 to 1 there's no x equals 0, there's no value of f of 0 that will give us this conclusion. So this condition cannot be satisfied. So this is why it does not contradict Rolle's theorem.